I listed 8 reasons why top balancing is better, but I really need to get into more details to explain why. The first one is top balancing works in applications that are seldom discharged. There are 2 classes of applications where that is true. Backup power and things like electric vehicles, power tools, things that get discharged but not always all the way. So in the class of batteries that are normally kept full and are only discharged on occasion because of a need, you will realize that the cells are fully charged most of the time, so why not take advantage of it and balance them at the top, and instead of hoping that sometime they may be fully discharged so we can do a bottom balance on it. The other class, things like electric vehicle, are always charged all the way overnight for an electric vehicle and are not always fully discharged. In fact, in the case of an electric vehicle, you rarely want to discharge all the way because you may not be home yet, and if you're fully discharged, you are not going to get home. So in these classes where we know that either you're always fully charged or you're seldom fully discharged, top balancing makes more sense because that's the most convenient place to do it because you often are there. The second reason is that top balancing allows batteries to store more energy. This one requires the understanding of the difference between charge in a cell and the energy in a cell. Now, a given charge in a cell is identical no matter whether you look at it at the bottom or at the top. So if you use just the top 50% of a cell, or if you only use the bottom 50% of the cell, the same charge, no difference. However, the energy is different. And the reason the energy is different is because the voltage of the cell is different whether you're on the top or on the bottom. So the same charge at the top of the cell carries more energy because it's at higher voltage than the very same charge at the bottom because it's at the lower voltage. Let's make some examples. Let's consider a simple battery of 2 LiPo cells, meaning 4.2 volts at the top, 2.5 volts at the bottom. And they're both 100 amp hour, except that one cell is not quite as good. In fact, it's only 50 amp hours. So it becomes the limiting factor to the amount of charge that the battery can carry. And the reason for that is pretty simple. If the 2 cells are top balanced and you start discharging when you get to 50 amp hours out of the battery, the 50 amp hour cell is totally empty, even though the 100 amp hour cell can still have some energy in it. It can't deliver it because the 2 cells are connected in series. Similarly, with bottom balancing, they're fully discharged. You charge, you put 50 amp hours in the battery. The cell with low capacity is limiting factor. It stops when it's full. And even though the cell with higher capacity still has more energy available, it can't do it because the 2 cells are wired in series. So we have a 50 amp hour battery consisting of 2 cells, where the 50 amp hour cell is the limiting factor to the 100 amp hour cell. Now let's look at how much energy can we store in that battery in the 2 cases. In order to really do that, we have to do an integration of the battery current times the voltage at the time across the battery. That's more complicated than I want to do here in this video, so instead we'll simplify it and we'll look at the energy as the voltage of the full battery times the charge that it can deliver, which is 50 amp hours. So case 1, top balancing. Both cells are full, 4.2 volts for each, or 8.2 volts for the entire battery. 8.2 volts times 50 amp hours is 410 watt hours. Remember the number. Now let's try it the other way. Let's bottom balance the battery, meaning that both cells are empty, and start filling them up 50 amp hours, at which point the cells that's as far as you can put into this battery. The high capacity cell is only half full, meaning its voltage is about 3.6 volts. The low capacity cell is completely full, meaning its voltage is 4.2 volts. 4.2 volts plus 3.6 volts is 7.8 volts times 50 amp hours is 390 watt hours. We were able to store 410 watt hours if we did top balancing, but we can only store 390 amp hours if we do bottom balancing. So we lost 20 watt hours that way. So there's the reason why top balancing allows you to store more energy into a battery. The next reason is that top balancing allows loads to run longer. And this has to do with the fact that when a cell gets empty, its resistance goes up and its voltage goes down. Now, if you're top balanced, there's only one cell to which that happens, because you're coming down with 10 cells, and at a certain point the low capacity cell starts dropping out in voltage and starts going up in resistance. But it's only one cell. If on the other side you have bottom balancing, you start coming down, and then all at once all of these cells whoop drop down in voltage and whoop go up in resistance. So the pack voltage goes down radically at the end because all of the cells are going down in voltage, and the pack resistance goes radically up at the end because each individual cell is going up in resistance. And therefore the load shuts down because it cannot keep on pulling out that much current out of the battery because of the lower voltage all at once, and the higher resistance times that current decreases the voltage even further, therefore making it the worst of both cases with bottom balancing compared to top balancing. The fourth reason why top balancing is better is that it's the only way acceptable to charge ThunderSky / Winston cells. Winston cells have an internal chemistry that requires you to hold the cell voltage at 4.0 volts for some time and on a regular basis. That the chemicals, I'm not a chemist, but the chemicals inside the ThunderSky cell will balance internally when the cell is sitting at 4.0 volts. Now that word balance has nothing to do with balancing a battery, which is what we have been talking about. It's just a chemical process happening inside the cell, and it happens at 4.0 volts. If you don't get to 4.0 volts, something happens, I don't know what, but the cell is not happy. Let's talk about bottom balancing first. You start bringing up the cells up at the same time, and the cell with the lowest capacity is the first one to reach 4.0 volts, at which point you stop charging because otherwise you would overcharge the one cell. So this one cell is at 4.0 volts. The other ones are at a lower voltage, so that chemical process is not occurring. That one cell is being taken care of by the 4.0 volts. The other ones are not. This one cell is going to be happy and stay happy over the ages. The other ones are not, and they're going to supposedly get worse and worse with time. On the other side, if you do top balancing, when you bring up the cells, they all reach 4.0 volts at the same time, and they sit at 4.0 volts. 4.0 volts. And therefore they are all happy, they stay happy similarly, and they age consistently with respect to each other. Those were the first 4 reasons. I'm going to talk about the next 4 reasons in the next video.